In grade 5, this is Mr. Boolsen calling in from sunny Muskoka. Well, today's not as sunny as other days have been, but you know what? It looks nice. I can hear the birds tweeting outside, and I'm looking forward to going on a walk soon. So, we're going to get through some math here. We're continuing with fractions. I hope the last video with the Irish accent wasn't too hard to understand, but we're going to have to continue. I might do this one partially in a southern accent, at least for the beginning, and then just switch over to the regular sort of talking way. So, to start off, I just wanted to show you that, well, there's a mental math minute, but I'm going to skip that, and we're just going to jump right into the fraction part. So, when we're talking about fractions, we want to start off with this. We were talking about equal parts. Remember, we talked about that in the last video. Equal parts, right? Now, I was showing you how it was with like a circle. You can do it with a square, but in real life, a lot of times, you're not dealing with just circles and squares and other things. So it can actually be equal parts of anything, right? It can be equal parts of flour, for example. So you can get, and you might have done this with your mom, you can get a little cup. Say this is a cup of flour, right? And so that is a cup of flour. We'll just say that is 1 cup of flour. And sometimes, this is where you probably see fractions most, sometimes they ask for a half cup of flour. So the way you can do this is either you fill your 1 cup half full, or a lot of times you get a set and it'll come with a smaller piece. Now I know my drawing doesn't look particularly smaller, but you get the idea that there you get a smaller one, then you get a 1/4 cup, and you have even a smaller little cup there, and they kind of normally they all fit inside of each other. And so yeah, the idea is that you get they're smaller, and then if you had 4 of these cups put together, you'd have the same amount as 1 cup. And so there's equal parts of this cup that are divided. Now, so that's the concept there, that it can be equal parts of anything. And so you could say have 3, well, a few guys here. These are, I'll call this one Tim. He's got a baseball cap, and this one is Stu. He's got a nice hat there. He's a upstanding fellow. And we got Tim, and he's got another hat. He's working out in the fields, Tim's a field worker. And so there he's got his hat. And then we got Jim and Fred. Now, if I was to ask what fraction of these people have hats, what are you going to do first? Well, you're going to figure out how many people there are. So you say, well, there's 1, 2, 3, 4, 5. So there's 5 people, and 3 of them have hats, and so that's the 3 hats. So you would say 3/5 of the people are wearing hats. And so you see how these are all equal people. God created them and equal, as the Constitution says. And yeah, you can see that all these people there. There are 5 of them, and 3 of them are wearing hats. So remember, this was the numerator, and this was the denominator. And as we talked about, this is how many parts of the whole that we're talking about here. And so the whole group is made of 5 people, and 3 of them are wearing hats. And that's kind of our focus here in this question. And so we put the 3 there, and the 5, the whole amount, which is the total, or the whole, that goes there. So I hope you get that it doesn't need to be squares and stuff. So sometimes you'll find questions that won't be dealing with squares, and they'll be asking things from you. So we'll just go properly, and you need to say, remember that when you're talking about these things, say you have 5/19. you have to say it like 19ths, right? So that's important. You have to say this properly. And you have to remember that it's not 5/19s, it's 5/19ths. So yeah, just that's another quick note. Okay, so now we're just going to see identifying fractions of sets. So if I draw this here, guys, for you, and you have this, okay, we'll shade that one in. We have a circle, shade this circle in, and we have this circle. Now if I say of these shapes, so of the shapes, how many are shaded? What would your, or what, yeah, I guess what fraction rather, we'd say what fraction are shaded? What would you say here? Well, first off, you want to look at what we're talking about. We're talking about the shapes in general. So we want to say that that is all the shapes that we're dealing with. And we count them. 1, 2, 3, 4, 5. So we know that there's 5 shapes. And so this one is going to be our denominator because that's the total, right? So we have 5 shapes. And what fraction are shaded? And so the shaded ones are going to be in our denominator, and we count them. There's 2. Now, if I say, how many circles are there in the drawing here? Well, we keep the same denominator, and so we would just say circles. And of the shapes, there are 3 circles out of 5. So 3/5 are circles. And then if I said, so instead of shapes, if I said, here, I'll just erase that. If I was to say, of the circles, what fraction are shaded? Now we have kind of a different situation here. What do you think, just for you guys to think for a moment, what do you think is going to be our bottom number, the denominator? What is going to go into that box there? And what is going to go into this box here? So first off, this is the denominator. So what is the total group that we're talking about now? Are we talking about all the shapes or something more particular? In this case, we're talking about something more particular. We're still dealing with the same group of shapes, but this is asking of the circles, what fraction are shaded? And so how many circles are there? Well, 1, 2, 3. So we have 3, and then you know, okay, how many of the circles are shaded? 1. So you have 1/3 shaded. So that would be your answer. Anyway, so that's how it goes. We will just continue now, and we will look at our final part here. So what you're going to encounter is word problems occasionally. So let's take this for example. A basketball, well, that's not supposed to be. A basketball team, London Lightning, played 5 games and won 2. So the question would be, what fraction of the games did they win? Okay, so what are we dealing with here? We have The basketball team played 5 games and won 2. So what fraction of their games did they win? And so we know there's 5 games total, and so what would be our denominator? If they played a total of 5 games, the whole amount of games they played was 5, and that's the denominator, because the denominator is the whole, and up the parts in the whole. And so of those parts, they won how many? 2. So what would we say here? We would say they won 2/5 of their games. And if we wanted to say how many they lost, we could figure that out too. So if they won 2 of their games of 5, well, obviously, if just to make it simple, the total's 5, you minus that by 2, it's going to equal 3. So they lost 3/5 of their whole games. And so you see, that's how it works. Now, I want you guys to send a picture in of you figuring this out. How many? So I also included this in the work plan, so you can find. I'm not going to draw it here. How many face cards there are in a deck? Oh, that's terrible. Yeah, how many face cards there are in a deck of cards? So, yeah, if you just want to go take a look in a regular deck of cards, how many face cards there are, and what fraction of the total that is. So I've included that question in the work page, or in the plan, so your parents can just get that for you. So yeah, that'll be just fun, and you can figure it out for me and see if you are understand this. Now, for now, that's Mr. Boolsen signing off. Bye, guys. Till next time. Ciao.